हेलो एंड वेलकम टू द चैनल एड्यूजोन लर्निंग सोल्यूशन। सो गाइस, आज के इस वीडियो में मैं आपको पढ़ाने वाला हूँ पार्ट 2 of chemical thermodynamics. So I want your full attention over here because we had completed your part 1, right? So in part 1 I had discussed with you the basics concept, right? So if you had not seen, then also it's fine, you can see after this video also. So it's a request to you all guys that please watch this video fully till end. If you found anything wrong in this video or any difficulties, then you can let me know in the comment box below, right? So let's get started. So I am starting the video. Before that, I would like to subscribe. I would like to say you all guys that please do subscribe, right? So because it increase my motivation also. चलो तो ठीक कर चालू करते हैं अभी और okay. So we would start. ओके, सो पहला टॉपिक क्या है हमारा? नेचर ऑफ हीट एंड वर्क। नाउ नेचर ऑफ वर्क, अभी हमने कितनी बार समझा है? हीट एनर्जी, वर्क डन, टोटल एनर्जी, काइनेटिक एनर्जी, right? Potential energy. They are the different types of, or we can say the different form of energy. So now in chemical thermodynamics, what role this work plays, right? So जैसे कि हमें पता है work done is equals to your force into displacement, right? आप देख सकते हो यहाँ पे फॉर्मूला भी लिखा हुआ है, वर्क डन इज इक्वल्स टू फोर्स इनटू डिस्प्लेसमेंट. In mechanics, the work is defined as the energy, right, by which body is displaced to a distance d with an application of force. ठीक है. But in thermodynamics, the type of the work involved in pressure, volume और PV work. फिजिक्स में हम लोग कैसे देखते हैं? W इज इक्वल्स टू एफ इंटू डी, इस तरीके से देखते हैं. ठीक है. सो या तो फिर हम लोग इस तरीके से देखते हैं आपका जैसे कि हो गया आपका पावर इनटू वॉल्यूम. सो अलग अलग फॉर्म होता है, राइट? सो इन थर्मोडाइनमिक्स द टाइप ऑफ द वर्क इन्वॉल्व इन प्रेशर एंड वॉल्यूम. ठीक है. सो अभी प्रेशर हमको पता है क्या होता है. प्रेशर इज इक्वल्स टू फोर्स अपॉन एरिया, राइट? चलो, सो दैट इज वर्क इज डन देन द व्हेन द सिस्टम गैस एक्सपांड्स. जब भी किसी सिस्टम के अंदर मूवमेंट होता है, लाइक सपोज जो मैटर है वो गैस है वहाँ पर. सो गैस में मूवमेंट होना, व्हेन गैस एक्सपांड्स और व्हेन गैस गेट्स कॉन्ट्रैक्टेड. सो ये सारी चीज़ें क्या है? ये वर्क डन हो गया. ठीक है. आपके सिस्टम के अंदर एक वर्क डन हुआ. सो यहाँ पे हम लोग जो है एक्सटर्नल सराउंडिंग्स को जो है फिलहाल इग्नोर कर रहे हैं. ठीक है. So it may be realized that the product of pressure and volume is equal to the work. यानी PV is equals to your work हो गया, बराबर. और work क्या होता है आपका? ठीक है. So over here pressure is defined as force per unit area. We know that pressure is equals to force upon area, or we can also say that force is equals to pressure into area, right? So if D is the distance, area is A, so we can assume that your A is equals to D square, or D square is equals to A, or we can also assume that your D is equals to under root of A, right? But over here and volume, we have to consider the volume, right? So volume is your d cube. So what would be your formula, final formula? So it would be your F into D. Now how? Because over here you can see that PV is equals to F upon A into V. So now A is your D square, V is your D cube. So it comes what? F into D, right? So now you're getting the point. So as you know, the now short glimpse of how your work will be compared in the terms of pressure and volume. So now we are going to see the decomposition of H2O2. There are some type of reactions which we had already learned in the class 10 also. Composition reaction, displacement reaction, decomposition reaction. This all we had already learned in our previous classes also, right? Now we are studying in class 12, so we will see that fastly, right? So over here you need to analyze two things, that is before and another is after. Now before, we can state this as what? We can state this as initial. Are you getting the point? Before means the initial term, or we can say any action has not occurred yet. कोई भी एक्शन अभी तक परफॉर्म नहीं हुआ है, राइट? समझ में आ रही है बातें? आफ्टर रिएक्शन, आफ्टर रिएक्शन मीन्स सिस्टम में कुछ जो है छेड़छानी हुई है, राइट? So after reaction means like we are talking about the chemical thermodynamics. So what could be the reaction over here? It could be obviously in the form of chemical, right? You getting the point? So it would be in the form of chemical, which could be your anything, any atom, any molecule, any of the chemical substances. So over here we have to consider your compound as H2O2, which has, you can see the 2 H2O2, right? 2 moles of H2O2. So it has been break down into two different substances, which we can say as a water H2O molecule, which is in the form of liquid, and another one is in the form of gas, which is your O2, right? So this is the type of reaction where you can see, you can assume that this is the part of your oxygen which has been break down, and this is your part of the water, right? So this is actually the action had taken place over here. Now reaction between NH3 gas and HCl gas. Now what happens over here? So these are going to basically add over here. This reaction progresses, the gases are consumed, like they are going to consume, they are going to get contracted, they are going to now merge, right? So this is the word you can understand over here, in a decrease of volume. So after getting merged, they will decrease in the volume, their size will become very small. So the piston moves down here, the piston is, you are going to move that down. You can see the compound here, NH4Cl. This is the before one, this is the after one case, okay? This is the reaction of NH3 and HCl. In the process of surrounding lose energy to the system and perform work on the system. If no heat transfer occur, work done by the surrounding is equal to the gain in energy by the system. This is PV work. Now what is happening over here? No heat transfer is occurring in this, like, right? So no heat transfer occurs, work done by the surrounding, right? So it is equal to your gain in energy if no action is going to take place, right? So this will be your like in the form of PV, right? So this is PV work, we can say PV work. Now nature of heat, what it is. So like heat is a form of energy by which the system exchanges energy with its surrounding. When the system and its surrounding are at different temperatures, heat either flows in or let out of the system. This is basically the motion of the system, which it is saying that your heat can flow where, in or out. Now we are talking about what? We are talking about system, right? So system is your place and heat is your energy, which is going to take place in the system, and which what action will it take place? Transformation, right? Now transformation is going to take place in and out, like from system 1, system 2, surrounding, it is going to exchange the energy, right? So this is the nature of sign convention. Yes, it is most important. So you can see the on system it is positive, by the system it is negative. If we are applying, then it is positive, but it is reverse, then it is negative. If we are heat is getting absorbed, then it is positive, but it is when it is getting released, then it is negative, right? So heat is released by the system to the surrounding, that is negative. Work done on the system by the surrounding, that is positive. See the denotions also, right? These are the denotions. Minus Q representation, how we denote that, plus Q. Work is done by the system on the surrounding. Note W and Q are path functions. These are what? your path functions. Expression for pressure volume work. Now you can see this is the your expression for pressure and volume work. Now over here you can consider any of the chemical substances. Consider a certain amount of gas at constant temperature P, which is enclosed in a cylinder fitted with frictionless rigid movable piston of area A. Now consider this is as your cylinder, right, or container. Getting cylinder or container which has some matter inside it. That is what over here it is mentioned, gases. Okay, so gases is your matter, gas is the matter which is present inside it. So now pressure is going upward, and you can see V1 and V2. It is creating two different volumes which has some respective displacement or distance within two different components, right? So pressure, you can see it is applied from the ground to above. So this is the expression for your PV work. So how it happens, you need to draw the diagram in the exams too, so that the examiner will understand that yes, he know the concept, he or she know the concept very well. Okay, so now coming up to the point, our F is equals to P into A. Now it depends, the sign is almost your depends on the direction, whether it is inside or outside, so that doesn't matter. You can read the content. If it is mentioned, yes, it is mentioned that external, right? So it is negative over here, or else you can mention that positive, no issues over here. Okay, so work is your force into distance again, but by the substitution we know that the formula is your P of external into A into D, right? Force is equals to pressure into area, and your work done is equals to force into displacement. So you have to just substitute. So what will be the word? W is equals to pad, right? So your A into D is what? Your volume. So you can ultimately write this as W is equals to PV, isn't it? Got that point? Are you getting this? So your volume will be del V will be V2 minus V1, which is we can write as final minus initial, which will give you a net value. Okay, so now moving forward, units of energy and work. Now there are some as you know that units and SI unit and dimension is very important thing over here. You need to know the SI unit for everything. Like in joule, we know that it is kg meter square per second square. We can say that force into force into distance, right? Or pressure into volume. So these are the terms. So pressure into volume is your Pascal into meter cube. Now 1 Pascal is equals to 1 kg meter inverse second upon second square, or s raised to minus 2. How we denote that? We denote that as your pressure is equals to force upon area, right? So force upon area is equals to kg meter inverse second inverse raised to minus 2. Okay, so these are some values where 1 bar is considered as 10 raised to power 5 pascals, which is also known as 10 raised to 5, or 1 lakh kg meter inverse second inverse raised to 2. So you need to take care of this units, right? Now coming up to example, you can see that there are 3 moles of an ideal gas are expanded isothermally. How it are expanded isothermally from 15 d meter cube to 20 d meter cube, right? So what is your d meter cube over here? It is your volume basically. Okay, so at constant external pressure of 1.2 bar, estimate the amount of work in d meter cube bar and joule. So we know that the formula for work done is your P into V, right? So external, it is written that you have to mention that in the terms of minus negative sign, because that is the rule of your sign convention. So P external is given as 1.2 bar, your volume 1 which is given as 15 d meter cube, and V2 is given as your 20 d meter cube. Now substitution of this quantities into the equation gives you right? Work done is equals to 1.2 inside the bracket 20 minus 15, which will going to give you the volume value as 100 joule, right? So now work is equals to minus 6 over here. You can see the term minus 6 d meter cube bar into 100, so you can write that as what, minus 600 joule. Okay, now coming over here, you can see that expression for the maximum work. Now what is maximum work? It is kind, or it is the state of the work which performs at a maximum level, like the value, the peak point, right? Getting, so your volume which will be the constant, your temperature, like over here it is written that consider n mole of the ideal gas enclosed in a cylinder fitted with a frictionless movable rigid piston, right? So it expands isothermally and reversibly from the initial volume V1 to the final volume V2. It has some initial volume, and you can see that final volume is V2 over here. At temperature T, the expansion takes place in a number of steps illustrated in this diagram. So this is the reversible expansion, so it will take infinitesimally slowly, right? So step 1, step 2, step 3 and continued will give you the system. Here you can see the system, the matter consisting is of what, it is of gas, but it is increasing its area by the term dV, right? Because it is not always same, it is getting changed, right? So now you can see when the volume of the gas increase by an infinitesimal small dV in a single step, the small quantity of the work done is written as W is equals to minus P of external into dV, right? Is that clear? Again, PV is equals to your work done, so you can write this as PW is equals to minus P into dV. Now why dV, why not dP? Because your pressure applied is the same amount, it is not getting changed. So what is getting changed over here? Here the dV term is getting changed, so you need to mention dV and ultimately dW, because it is changing your work done also. So as the expansion is reversible, P is the greater by the very small quantity dP, then P external would be written as P external is equals to P minus P dP. So this is the constant term you can look at upon, like dW is what, your, okay, so your dW is equals to minus P minus, you can see this of external sign, or and this is of your final minus initial, P minus dP into dV, which can further written as minus P dV plus dP dV. Now this is not going to get cancelled, this is going to give you the proper term, proper net value, so which is very small over here. So dW is equals to minus P dV, which is very small. So thank you guys, that's it for today. If you like this video, then please do like, share with your friends, and please do subscribe, right? Because it would give me motivation as well, and you are also going to get the latest notification. So I'm going to cover all your physics, chemistry and math. So if you have not visited our channel, then please do visit, have a look. If you have any suggestion or any of the advice, then please let me know in the comment box, right, which is open your 24 into 7 into 365. Okay guys, so thank you, that's it for today. If you are liking this video, then please do like, share and subscribe. So we'll get you in the next video. So till the time, take care, thank you and bye bye.